Dear students, this is the continuation of the previous video. Okay. See this example. Write all solutions of 9x congruent 15 modulo 23. Okay. And identify the unique solution over 0 less than or equal to x less than 23. Okay. Now, you see here, we have found the inverse of 9 modulo 23 in the previous video. You see, we do the same procedure first. We apply the equivalence algorithm. First we find, you see, the GCD of 9, GCD of this number 9 and this number 23 first. Okay, as we explained in the previous video, we can do that. Okay, so that now you see x not equal to minus 5 is an inverse of 9 modulo 23. Okay, after this what we do? Now we see here, we consider the given equation as 1, equation number 1. Okay, and this equation is equation number 2. Okay, now what is the inverse? That is minus 5, which we found already in the previous video. Okay, that is minus 5. Inverse of 9 is minus 5 modulo 23. Okay, now what we do here, see, we are going to find the solution of this linear congruence. Okay, now see here, what we do, multiply equation 2 by 15. Okay, see, this is equation 2, we multiply by 15. See, this is the equation 2. Okay, we multiply by 15. So what will happen, you see here, 9, I keep just 9, then minus 5 multiply 15 is minus 25 congruent. Here you multiply 15, so 1 become 15 and modulo 23. Okay, see, I multiply 15 here and here. Okay, so now 9 times minus 75 congruent 15 modulo 23. Okay, this is what, see, modulus equal to the given linear congruence. Okay, so now you see here, what is x? If we compare, we can see what is here, 9 into x, but what is here, 9 into minus 75. So that this is the solution. Okay, but here what we need, identify the unique solution over 0 less than or equal to x less than 23. Okay, in between 0 and 23, it's greater than 0 and less than 23. What is the unique solution? Okay, so for that what we do here, you see, that is x is equal to, see, this value minus 75 modulo 23, you apply modulo 23, you write the remainder. What is the remainder? That is 17. See here, this minus 75 is equal to minus 4 multiply this modulo value, that is 23, plus remainder is 17. So when you divide this minus 75 by 23, your remainder is 17. That is here. See, this value 17 is nothing but lies, see, between that 0 less than or equal to x less than 23. This x is now 17. Okay, so that is the unique solution between 0 and 23. Okay, now see here, we write all solutions. How to write all solutions? You see here, for any integer k, x is equal to minus 75 plus 23k. How we write this? See, from this equation, from this linear congruent equation, see here, minus 75 we can write, then plus 23 is the given modulo, then k is nothing but the integer. Okay, so that this is all solutions of the given linear congruence. For example, you see, now another way also we can write 17. You see here, now suppose you write k is equal to 0. K is an integer. Suppose you write k is equal to 0 here, then you will get minus 25. Suppose you write k equal to 1 here, then 23 into 1, that is 23. So minus 75 plus 23, you will get another value of x. Similarly, if you write k is equal to 1, 2, 3, then you can find different values of x. Suppose you write k is equal to 4, then you will find x is equal to 70. Okay, that's it. Now you see here, what is this? Chinese remainder theorem, that is CRT. The Chinese remainder theorem is to solve a set of congruent equations with one variable but different modulus, okay, which are relatively prime, as shown below. See, x congruent to a1 modulo m1, x congruent to a2 modulo m2, etc. x congruent to ak modulo mk. These are the set of all congruent equations with one variable x. Okay. Now the Chinese theorem states that the above equations have a unique solution if the moduli are relatively prime. Suppose these modulus values m1, m2, mk are relatively prime, then Chinese remainder theorem says that this is having a unique solution. Okay, we'll see an example for the CRT, Chinese remainder theorem. Write all solutions to the system of linear congruences by Chinese remainder theorem, CRT. Okay. Now, x congruent to 2 modulo 3, x congruent to 3 modulo 5, x congruent to 2 modulo 7. This is means given linear congruences. Okay. Now, if you compare with this general format, now I can write what is a1? a1 is 2. This a2 is 3. a3 is 2. Okay. I'm writing here. Then m1, this modulus value. So m1 is this. First m1 is 3. Second m2 is 5. M3 is 7. Okay, I'm writing here. And we can verify this also. 3, 5, 7 are pairwise relatively prime. I'm writing here. How? See, 3 and 5 is relatively prime. 5 and 7 relatively prime. 7 and 3 relatively prime. That's why I write 3, 5, 7 are pairwise relatively prime. Okay. Now, next we have to find m. What is m? You multiply m1, m2, m3. What is m1? 3, m2 5, m3 7. So you multiply all this, that is 105. Okay, fine. Now what is z1? Nothing but m by m1, so that is 35. z2 m by m2, that is 105 by 5, 24. Similarly you can find z3, that is 15. Okay, now actually this is a method how to find the unique solution x. Okay, now you see here, consider this linear congruence. Z1 y1 congruent to 1 modulo m1, that is here what we have calculated z1, that is 35. So you substitute here 35 y1 congruent 1 modulo 3. Okay, now what is our aim? Why we do this? Why we start from this congruence equation? Now we are going to find the value of y1. I'm going to find the value of y1. Okay, now see, this is the linear congruence. Now by equivalent algorithm, see, I can divide 35 by 3. So remainder is 2. So 35 is equal to 3 multiply 11 plus 2. And then you take 3 and 2. That is 3 is equal to 2 into 1 plus 1. Then you take this 2 and 1. So that now 2 is equal to 1 into 2 plus 0. So now here what is the GCD? That is 1. So that by back substitution you can rewrite 1 is equal to 3 minus 2 into 1 from this. And then 3 minus this 2 is 35 minus 3 into 11. So that I can write this, see, 1 into 3, this 3 into 11. That is 11 times 3, here 1 times 3, so 12 times 3. This is nothing but minus 1 times 35. So I can rewrite 1 is equal to 12 times 3 plus minus 1 times 35. This is the linear combination of C, 35 and 3. See here, we are getting 3, we are getting 35. Already we have seen 2-3 questions, 2-3 examples. Now if I write, see, the 1 as a linear combination of 12, means linear combination of 12, linear combination of 35 and 3, then I can write this congruent equation. Yes, yes. So now see, from this how we write this? See, here I can say the inverse of 35 is minus 1. Suppose I want the positive one. Okay, 0 less than or equal to x less than or equal to 3. So that what I'm writing here, see, with this minus 1 I add 3. So that I will get 2 multiply 35 congruent 1 modulo 3. Okay, this is right. So that from this equation I can confirm that 2 is the inverse of 35 modulo 3. So what is the C? You see this equation and you see your first equation. Now you compare this. So here y1, here I have 2. So y1 is 2. Okay, here if you get the negative 1, this is also correct. Minus 1 is the inverse of 35. But I want the positive. So that I am writing here, see, I add this modulo value 3 with this value minus 1. So I am getting 2. So now y1 is equal to 2. Okay. Similarly, what I am doing from this equation is z2 y2 congruent 1 modulo 2. See, I can write z2. Already we have found. What is z2? That is 21. So I write here 21 y2 congruent 1 modulo 5. So that here by equivalent algorithm 21 is equal to 5 multiplied 4 plus 1. Then I can rewrite 1 is equal to 1 multiplied 21 minus 4 into 5. We have done so many questions earlier. So now from this I can write this linear congruence. So now I can say 1 is an inverse of 21 modulo 5. So y2 is 1. So the second one is how to find y2. Okay. Similarly, I can find the value of y3. See, I can write this equation. From this equation, see, z3 I can substitute. Then I have to find y3. What is y3? y3 is 1. Now, how to find the value of x? That is equal to, this is the rule. a1 is z1 y1, a2 is z2 y2, a3 y3, a3 is z3 y3. We have to add all. So that now you substitute all the values of a1 is z1 y1, a2 y2 is z2, a3 y3 is z3. So the value is 233. Okay. Now, but x is 233 is bigger than our modulo value. So now you see here what I'm doing. I'm finding x is equal to 233 modulo 105. See, we have done in the previous question. Okay, in a similar way, if you write, then x is nothing but 23 is our solution. So what is what is the form of all solution? That is nothing but for any integer k, x is equal to 23 plus 105k or solutions. This is called all solutions. Okay, for all values of k, means k is integer. So if you replace k by any integer value, you will find x, different x. Okay, that is all solutions of the given linear congruences. That's it. So this is the way how to apply CRT to solve the set of all linear congruences. Okay, thank you.